In the present example, we give the function fxy, that is 3x squared minus xy, and we say if delta x and delta y are increments of x and y, we want to find the delta x. That's we are given delta x, delta y, we want to find delta w. So change in the function. Then we use this delta w to calculate if our point is moving from point 1 to point 1.01 and 1.98. Now, this x1, when you say here, when it is changing from this, and we having the value of x1 and x1, y1, x2, y2, we can find delta x, delta y. So here, part A, we just first find delta w. What's my delta w? My delta w, as defined before, the exact value will be x plus delta x and y plus delta y minus fxy. So this is my formula. So here I need to find fxy is given. I find here x plus delta x and y plus delta y, and then substitute in this one. This is my number one. So we find here f of x plus delta x, y plus delta y is equal to, we are having here 3 into x plus delta x whole square minus x plus delta x. We replace x, and also y is y plus delta y. Now we do some mathematical work and make the simplifications. We are having here, when we just open this one, we have 3 into x squared plus 2x delta x plus delta x whole square. It's easy, you can do it yourself, minus. Now we multiply x plus delta x and y plus delta y, multiply by x, we have x, y plus x delta y, multiply by delta x, we have y delta x, and then we have y plus x delta x delta y. So we open this one, we can have here 3x squared plus 6x delta x plus 3 delta x whole square. Then we have minus xy, multiply minus each of the term, because we are opening this one, and that don't forget it to change the sides. Now we take the values without delta x, with delta x, power 1 and then power 2. So get here 3x squared minus xy. So here is minus xy. Then with the delta x and delta y, we have 6x delta x. Then we are having minus x delta y. Get here y delta x. Then the power is 3 delta x whole square minus delta x delta y. So that's my value of f of x plus delta x. Now I substitute this value in my equation 1. That's the value minus the value xy. So we get here, this is my number 2. I substitute in my equation 1. So I am having here the value of delta w is equal to f of x plus delta x. We substitute here. This is my f of x plus delta x. We substitute the value here. What I will get? I get here 3x squared minus xy, then plus, I combine these two terms together. We have 6x minus y into delta x. Then I have the term with x delta y. Then we have these the last two terms. There's 3 delta x whole square minus delta x delta y. So this is my first term. Then the second term is minus xy. Delta xy is 3x squared minus xy. So now I just open this one and simplify it. I get here 3x squared minus xy plus 6x minus y into delta x minus x delta y plus 3 delta x whole square, and then we have minus delta x delta y. Here we open it to get minus 3x squared plus xy. So it's very interesting to note that we having here 3x squared and we having here minus 3x squared. We have minus xy and here plus xy. They are being cancelled, and we will get here the value of delta w is equal to 6x minus y into delta x minus x delta y. Then we have plus 3 delta x whole square minus delta x delta y. So that's my result. This value of delta w, that is the approximate change in w when we have the value of x and y both are changed. So this was the result for that one. The part B of this was that we want to find delta w, and we want to find delta w when our xy changes from 1.2 to 1.01 and 1.08. So I am having here, this is here 1, 2, it changes to 1.01 and 1.98. So I am saying this is just like this x1, y1 changes to x2, y2. So my delta x will be equal to x2 minus x1, and here my delta y will be equal to x1. Delta y is equal to y2 minus y1. I can just have this my x1 is 1 and x2 is 1.01. So my delta x will be equal to 1.01 minus 1.00. The result is 0.01. My delta y is equal to, this is my y1, this is my y2, 1.98 minus 2.00 is equal to minus 0.02. Very interesting to note that one. When the value is increasing, delta value, the increment will be positive, and the value is decreasing, the increment will be negative. As we were changing in x was 1 to 1.01, so delta x is 0.01, and change in y was 1.98 to 2, 2 to 1.98. y1 was 2 and y2 was 1.98, was decreasing. So increment become minus 0.2. So we have given here the value of x and y. So my x is 1, my y is 2. So this is x plus delta x, y plus delta y. I substitute in my result 3 to find it here. So my delta w is equal to 6x minus y. This here 6 minus 2. 6 multiplied by 1 is 6 and y 2. Delta x is 0.01 minus x into delta y. X is 1. Delta y is minus 0.02, then plus 3 into delta x square is 0.01 whole square minus delta x 0.01 into 0.02. So I simplify this one. We have here 4 multiplied by 0.01 is 0.04. Minus minus plus, we get 0.02. Then we get here 0.01 is 4 decimal places, 3. Then we plus 0.0003. Then this minus and this minus become plus. We get 0.0002. So this is what we get here. Now we add this one. We're adding this. This is 0.06. Then we're having here 0 and then we're having 5. And that's my exact value of delta W when my xy is changing from 1 to 1.01 and 1.98. So this is my example. We just extend our example 1 and we find the approximate change. With last we find exact change delta W. Now the same idea is the function is given the same function. We are having 3x squared minus xy, and our xy is changing from 1 to 1.01 and 1.98, and we want to find dw, the approximate value or approximate change. Then we make the comparison of these two. So to get that one, the formula we are having here for this one, our formula is dw is equal to partial w by partial x into dx plus partial w by partial y into dy. Now we know our dx is equal to delta x and our dy is equal to delta y, being the function, being the variables which are not the exact. Now find here partial w by partial x, rf of x, differentiating with respect to x, taking y as constant. So our function here become here 2x squared. So get it 6x, x squared become 2x, and here derivative of x will equal to 1, we get here minus y. And partial w partial y, taking x as constant, this will be 0 here, and then here this will value 1 and we get here minus x. So here we can write our dw is equal to 6x minus y into dx, and then we have plus minus x into dy. So here we can now find the values that we have here. This is our 6x minus y into delta x, as I shown you, because this is an independent variable and delta x dx is equal to delta x, we can change it, plus minus x into dy is equal to delta y. Now as before, we are having here the value of x is equal to 1, the value of y is equal to 2, then our delta x is equal to x2 minus x1 is equal to 0.01, our delta y is equal to y2 is 1.98, minus 2.00 is minus 0.02. We substitute the value here, dw is equal to 6x is 6, minus y, my y is 2, delta x is 0.01, minus plus minus x is minus 1, delta y, our delta y is equal to minus 0.02. Simplify and multiply, get a 0.04 plus 0.02, and this give me the value 0.06. So I have here the values of dw. My dw is equal to 0.06. Delta w we have calculated before is 0.0, and we can check it here 0.0, and in the last example 0.5. So this is my delta w. Now this way we can compare it, that we know this delta w is the exact value and dw is the approximate value. We can discuss the error, the difference between these two. So error are the difference between these two values, the exact value, this delta w minus dw. is equal to delta W is 0.0605, dW is 0.0600. So we get here the result 0.0005. So this is the error in our calculations when we are going to calculate the approximate value. But when you look on the steps of calculations for this one, so we have simply this formula and we substitute the values of the derivative in that one as we did here and we get the result. But here if we are going to find the approximate value, the formula we derived was this formula, and the number of steps we have made for finding this one, that's before us. Here in this whole slide we can see here that we find the value of f of x plus delta x, then we make the subtraction, simplification and all that, and then we get the formula. But here we can have very simple, but here there is an error. The error is the 0.0005. Sometime we can just sacrifice this accuracy and we can get the approximate value. And sometimes it's not possible to find the exact result. We always go for the approximate result, especially those of you who are going to study numerical analysis. There you can see it here, we use approximate methods. And in that one then we have the error analysis. We can find the error separately. And then if you want to find the exact value, then you just add that one, the error in the approximate value. You are very, very, very near to the exact value. So the methods in numerical analysis, when we develop the methods, that the beauty of the methods is, the research related to that one is that how accurate we can calculate, we can develop the approximate method for finding the result. So that accuracy that develops the new methods and new techniques, new ideas in numerical